You get home, park yourself in front of your computer and pull up Reddit. To your surprise, apart from the outcry of the public, net neutrality has been repealed. So you decide to accompany an internet equality group to the steps of the FCC building to protest. Well, you look to your favorite navigation app to show you the way. Now the reason that your phone, and by default the app, can pinpoint your location and then give directions is the result of GPS. What is this magical technology and how does it work? Let's get curious. We'll skip most of the history for now, but the important years were 1983 when Ronald Reagan opened the system to the public, previously military-only technology, but with reduced accuracy. Then in 2000, President Bill Clinton upgraded the public's connection to allow for more accurate positioning. Let's first get the acronyms out of the way. So top down we have GNSS, or the Global Navigation Satellite System, describing the entire ecosystem of regional GPS to include US, Russia, Chinese, Europe, India, and Japan. And GPS, which stands for Global Positioning System. And finally, colloquial to GPS, is Navstar, which is navigation system using timing and ranging. Time and range, or distance, being the big ticket items. You see, it's actually remarkably simple. Minus the design and construction of the satellite, strapping it to a rocket and launching it thousands of miles into space, which, contrary to popular belief, are not in geosynchronous or geostationary orbits. It is a serial communications device broadcasting a string of data constantly. Picture it as a speaker, if that speaker transmitted microwaves at around 1600 megahertz and 50 bits per second. Okay, so it is bombarding devices around the Earth constantly. What are they transmitting? Well, in a synchronous effort between each other, each satellite transmits its position and current time to within nanoseconds via an onboard atomic clock, which are synchronized with one another and ground clocks. Now these signals travel at the speed of light to the receiver, where the device calculates its position from the time of arrival and time of transmission values. At this point, however, the device only knows its distance from the one satellite, which would put it somewhere on a hyperboloid with its center at the satellite and an unknown clock bias. So what do we need? Exactly, we need more satellites. With a distance equation, we can start to back ourselves into our position with a few substitutions. Using what we know about the satellite and our device's clock time, we can compile our 4 equations and 4 unknowns, our x, y, and z coordinates, and our clock bias, which then can be solved algebraically. There is one caveat. It is common for a device to be receiving more than 4 signals, and for this the equation is overdetermined. Well, there's a multitude of equations used to combat this. I would suggest you search solution methods for GPS equations to learn more. Now this is all fine and dandy, but what if the satellites are lying? Well, I did leave out one important subsystem outside of the satellite and user device. That is the ground-based stations. Now, these stations constantly check in with the satellites to make sure they are where they say they are. If not, the satellite is marked as unhealthy, so the device knows not to use this specific satellite. Then changes to the orbit or predicted positions, known as the ephemeris, are fixed. Then engineers upload the new data and mark the satellite healthy again. So we find ourselves at the end and we ask ourselves, how has Uncle Sam's contribution to the general population improved our lives? Well, it is simultaneously subtle in appearance and impactful in use. From fitness, navigation, and tracking, to safety, logistics, and environmental concerns. GPS is a remarkable and life-changing technology. Hey, thanks for watching. If you enjoy these videos, consider liking, subscribing, and hitting the notification bell so that you're immediately notified when I come out with new content. Otherwise, come back next week for some more curious videos.